Okay, you guys, I just wanted to make a video of the key. I was having a really hard time converting it to a PDF. It kept cutting off parts of the problems and moving them to different pages. So it's just something I'll have to figure out down the road. So what I'm going to do is I'm just going to kind of slowly scroll through all the problems. So if you want to figure out, or if you want to see the solutions to them, you can kind of go from here. So here's 1A and 1B. Okay. Here's the solution. So you can pause the video and make sure that you're getting the right answers for these when you're doing the problems. And again, we went over all of these today, or looked at quite a few of them today in the meeting. So let me know if there's a hiccup or something. But other than that, remember, a few of you were asking about this one. This one's a little bit harder because it requires ultraviolet voodoo while you're doing the separable differential equation. So there's number 2A and 2B. What makes these different is they have initial values, so you can actually solve for C now. Okay. But again, all of these are separable. So I also added these. These are linear. This is some extra practice with linear. So let me zoom out for you on these. So here's a few linear differential equations that will be on the, maybe one or two of these on the exam tomorrow. So again, the stuff in blue was added after, I started the problem. So maybe I should write this. X, y prime plus 2y equals e to the x squared. So when you divide by x, you end up with this, and then I went from there. So here's our solution down there. I also wanted to show you this other problem over here, x squared dy dx plus 2xy equals cosine of x when y of pi is equal to 0. So here's this problem. So you should be able to go through and pause the video and then make sure that you're getting this one right. So here should be our solution right there. Okay. Let me see here. Now we did talk about this one. So I do believe I put an arc length problem on the exam, but this particular problem, number 4, we talked multiple times about this one in the meetings this whole week. This one's probably a little bit too long for the exam. The one I put on the exam ended up being much nicer. So don't stress too much about it. But after you do all the cleanup, you end up here. That becomes then you have to do trig sub or know a special formula. But for our class, we would use a trig sub, and then we would go from there. The final answer ends up being this. Okay. So don't stress too much about that particular difficulty level, but there will be an arc length problem on the exam, I believe. Let me see here. We went over this one, number 5. Let me zoom in on this. Here's number 5. So the slope of this, the slope of the tangent line at theta equals pi 6 for r equals 2 sine theta. So once again, you have to set this up by finding out what x and y are, because you're going to need to know dy d theta, and you're going to need to know dx d theta. After we do that, we end up with our derivative right here. So I will definitely want to see the derivative on the exam. And then right here, we have our answer. And this part over here is just a little extra, just in case, what if they ask you for the equation of the tangent line? Well, you could also find that as well. Okay. So here is an inner loop problem. I think this is the exact same one from the video. So here's this one. So you should be able to look at that. Here's a circle and a cardioid, I believe. And this one, let me zoom in a little bit for you on this one. This is number 7. So I think I must have zoomed super in when I was writing it. So there's some of the work, but it's a little hard to read just because it's so zoomed in. I don't know how close I can get. But anyway, there's that problem, number 7. Let's go to number 8. I had one of these on the test, but I took it off just because it didn't have the desired effect. So you could eliminate the parameter and end up with a horizontal parabola. And then you would build like a table of values like I did in the first video for chapter 9. I'm sorry, for chapter 10 or 12.1, whichever book you're using. Here's a rose petal. You should always know how to do the rose petal. They're kind of cool, knowing how to find their angular boundaries. Here's the work for it. If by any chance I had asked for all the area, you would just do one loop and then multiply it by 4, because there's 4 in this particular problem. In another one, there might be 8, and another one, there might be 3. Okay, and I think that's it, you guys. So hopefully you had a chance. Just pause the video. I'll scroll back over in case there was anything I missed, and you can just pause it. But yeah, that should be all the solutions to the key that we've gone over for the last 2 days, Tuesday and Thursday. Let me know if you have any other questions. Remember, our exam is tomorrow at 5 or at 12:45, depending on which school you're in. You should know at this point when you're taking the exam. If you have a problem, email me immediately so we can try to figure something out. But yeah. All right, you guys, that's going to do it. I just wanted to send out this short video.